Alright, hello everyone, welcome back to another Matthew Day channel. So in today's video we'll be looking at the exponential functions, right? So we'll be looking at the introduction to exponents, right? Exponential functions. Okay, so for instance, the exponential function is given as fx being equal to a raised to the power x. So this is what we call an exponent, right? Rather than exponential function, right? A being the base, and then the x being the exponent, right? So basically, the x can be any x can be any value, right? Can be a negative, rather can be anything in that case, right? And then a cannot be a negative, right? A has to be greater than 0 in that case, right? So this here is the expression for a for the exponential function, right? Of course there will be some addition where there will be x plus p plus q, right, and all that, but we will look at that later in this video. So an exponential function is basically a function that accumulates very fast, right? So it's used for accumulation, right? For instance, if we have f x equal to 2x, right? So what if my x in that case is equal to 10, right? So if I have f10, what do I get, right? So f10 with x being equal to 10, let us see what we get. So 2 raised to the power 10, we get 1024, right? So basically this is this function accumulate so fast, right? At x we have a y value of 1000, right? So this is basically the introduction rather to exponent, right? The exponential function is used for things that accumulate very fast. Okay, now we said that a is always greater than 0 in that case, right? Is always greater than 0, right? We do not include the 0, right? Because if a is equal to 0, then we will have fx equal to 0 power x. For x being any number, real numbers, that means that our function right, if x is any number, meaning our function now will lie on the x-axis, right? There will not be any function in that case, and hence why we do not include the 0. Now a has to be greater than 0, right? Let us see. We say that x has to be, or rather x is can be any number, can be a real number. So what if x is equal to a half, right? What if x is equal to a half, and then we have a being equal to -4, right? So we will have f(x) equal to -4x. Then we say that, well, x is equal to a half, and hence we'll have a half being equal to -4, rather a half, right? This will give us a negative square root. This will give us a square root of -4, which in that case will give us a math error, which in that case it does not exist, right? It does not exist, so meaning a in that case has to be greater than 0. My a has to be greater than 0, right? Okay, so now the things to note when dealing with exponents are the laws and properties, your laws and properties, right? So let us look at some the laws and the properties of exponents, right? So the first one, we have done this before, but just to recap, the first one is when I have the same basis, right? When I have the same basis, so here basically we're having the same basis multiplied to each other. What we do is we basically add the exponents, as easy as that, right? So the base stays as is, and then we just add the exponent. In that case, we just add the exponents, right? For example, if I have 2 to the power 2 times 2 power 1, right? What will I have? I'll have 2 plus 1, which would give me 2 cubed, because 2 plus 1 is 3, and hence 2 cubed, we know that is 8, right? But if we do it the normal way, so about that, we'll have 4, because 2 squared is 4, and then 2 raised to the power 1 is 2, and then 4 times 2 will give us the 8. So that's the first law, which is the very the important one to note. This one here is very important to notice, that one. So the second one will be the quotient, right, or division, right? If you have a raised to the power m and then a raised to the power n, we basically have a m minus n is basically the opposite of multiplication, right? So if you multiply, we're adding the exponents. If you divide, we're subtracting the exponent. Now notice here, when it comes to this one, the order doesn't matter, right? You can also have a n plus m, right? So the order doesn't matter, but when it comes to this one here, the order matters. So the numerator becomes the first the first number, or rather the first digit when you're subtracting, or rather the let me say it like this: the denominator is the one that will have the negative side, right? The denominator will be the one having the negative side. So for instance, if we have 2 raised to the power, let's say 7, divided by 2 raised to the power, oh, you know what, let's say 2 raised to the power 4, all divided by 2 raised to the power sorry about that, so 2 raised to the power 4, and then 2 raised to the power 1. Come on, so we have this, we'll have 4 minus 1, which will give us 2, 3, which is basically equal to 8, right? Now what if we say 2, 1 minus 4, right? Now we're changing the whole scenario. We'll have 2, negative 3, which in that case we have 1 over 8, and we notice that 8 is not equal to 1 over 8. So pay attention to this. Pay attention to these small things here, because most people do make that mistake. So the denominator is the one with the negative, right? Make sure that you understand that one. Okay, so let's do this the normal way. So you basically have 2 times 2 times 2 times 2, all divided by 2, and then because there's only 1 here, there's 4 2's, so I can remove this one, hence I'll have 2 times 2 times 2 which is the same as 1 1 1, so it's 2 1 plus 1 plus 1, which is 2 cubed, right? Just say 2 cubed is equal to 8, and which is the same as what we got there on top, right? So this is very important to note, right? This is very important to note. The order here matters. When we add, the order doesn't matter in that case, right? Okay, so this is m minus n. Okay, so then come to property number 3. Property number 3 is the easiest one. You have a m and then times n, right? So the most question many students asked is like, if you have like 2 raised to the power 2, right, and then raised to the power 2, so what they do is they say, well, this is the same as 2 is something that looks like that, which is wrong in that case, right? So you just multiply the two exponents, right? Just multiply the two exponents. So if you get something like this, or rather in that case it's mn. If you have 2mn, this will give us 2m times n, right? So for instance, if you have 2 times 2, this will give us 2 times 2, which is equal to 2 raised 4, which is 2 raised 4, which is 16, right? That give us 16, right? But if you say 2 raised to the power 2, I mean, it does give us 2 power 4 still. But what if I say 2 3 2, right? So in that case you would say 2 3 squared, 3 squared, which is equal to 2 raised to the power 9, and then 2 raised to the power 9 in that case will give us 5 1 2. But if we say 2 3 times 2 will give us 2 raised to the power 6, 2 raised to the power 6, which is 64 in that case. So here we got lucky there, because we know that 2 squared is the same as 2 times 2, so we got lucky for doing that. But when it comes to that one here, you can see that we getting different answers. So please take note of that property. It is very important. It is very important. And then number 4, right? Number 4, easiest one again. If we have a raised to the power 0, you basically get 1. So any number raised to the power 0 will give us 1. Of course, if like if you have 1000 raised to the power 0, you get 1. But if you say 2 raised to the power 1000, now this will give us 2 here, right? Because this this 0 here only applies to the 1000. So take note of the bracket as well. It only applies to the 1000. But what if I say 2 times 3 raised to the power 0? Now this is the same as 6 raised to the power 0, which is the same as 1. So just like this one here, when we have 2 times 1000 raised to the power 0, we cannot say this is 2000 raised to the power 0 being equal to 1, right? So these are the common mistakes that many students make. Please take note of these mistakes. Take note of these mistakes, right? Okay, so and then number 5. So number 5, on the list we have a raised to the power n negative, right? Let's say negative n. This will give us 1 over an. Why is that? So let's go back to property number 2, right? And let's look at property number 2 and property number 1, right? Let us look at those two, right? Let's combine property number 2 and property number 4, right? We said that my a, so to get 1, it can be any base raised to the power 0, right? So now let's make the base a, because we want to subtract, so we want to make the base a, then we're gonna let it be equal to 0. So in this case we'll have a raised to the power 0, and then we'll have a raised to the power n, right? Which is let me just write it here. Please take note, these two are equal here. So a raised to the power 0 divided by a raised to the power n. These two are equal because we just said that this now is 1. So now looking at property number 2, we have a quotient, or we have a division. What do we do? Well, we have a raised to the power 0 minus, right? Remember that the denominator always have the negative, so minus n, which we get what? We get a raised to the power n. So in this case here, this proves that these two here are indeed equal. So meaning if I have if I have 2 raised to the power 3, well, this will give me 1 over 2 raised to the power 3, which is the same as 1 over 8, right? So this is very important. This is very important here, this property here, right? Property number 5. Then looking at property number 6, which states that a 1 over m. So basically when my exponent is in the form of a ratio, or rather it's a rational number. In that case, if it's a rational number, being said 1 over m or 2 over 3, something over something, right? That's a rational number. So if we have a base raised to the power a rational number, then basically we can introduce a root, right? We can introduce a root. So in this case we have root m of a, right? So let's look at an example. So if we have a square root of 4, so now we know this, a square root, square, so I mean there's a 2 here, right? And this is a 1, so meaning this is what? This is 2, my bad. So this is 4 raised to the power half in that case, right? Raised to the power half. So you can see what is happening here. The 2 becomes the root, and the numerator becomes the exponent of the base inside the root, right? So we know that 2, or rather 4, is the same as 2 squared, right? 2 squared. So meaning I can say, well, 2 squared times a half. Now looking at property number 3, we know that this here can times these two numbers here, and hence we get 1, so we get 2 raised to the power 1, which is the same as 2. So meaning we can now conclude that the square root of 4 is equal to 2, right? We can conclude that the square root of 4 is equal to 2. Okay, just remove this. Yeah, man. Okay, there you go. Okay, so this is very important again. So any if we have an exponent which is a rational, which is a ratio, or rather a rational number, then we can change that into a root. The denominator being the root and the numerator being the exponent of the base, right? Exponent of the base. For instance, again, let's say you have 3 over 2, right? So remember that the denominator becomes the root, and then the exponent becomes the base. It becomes the numerator becomes the exponent of the base. So this is what we get, right? It is very important, which is the same as 2 8 in that case, right? Okay. Let's look at another property. I know there's a lot of properties I want to note, but trust me, these are very important, and they are basically easy. They are easy to remember, right? If you do what I do, or rather you do basically step by step, then you will get to know them. So they are basically easy to understand. So if you have 2 bases raised to the power m, then basically, I've said this again, the a will receive the m, and then the b will also receive the m. Now I'll have a raised to the power m, and then b raised to the power m, right? So this again is also common and easy. So for instance, if I have 2 times 2 raised to the power 2, so what will I have? I'll have 2 raised to the power 2 times 2 raised to the power 2, which is 4 times 4, or is 2 plus 2. See how nice is maths? Maths is very nice. So we get 2 raised to the power 2 plus 2, and then, or rather, we can have 2 squared is 4 times 2 squared is 4, and then 4 times 4 is 16, which is the same as 2 root 4, right? So this thing here, you see how I play around with the properties. So make sure that you are able to play around with the properties on your own, so that you better understand and be more confident when you're writing your exams when it comes to exponent, right? So this is basically, this will give us, what we say, gives us 16, right? So the answer here will give us 16, or you could have said 2 times 2, which is 4 squared, and then notice that 4 squared is the same as 2 squared, which is the same as 2 times 2, right? Which in that case will give us 2 raised to the power 4, which is 16. Very important. So we notice this. Now I had 2 squared times 2 squared being equal to 2 squared times 2 squared, but again is the same as 2 plus 2 squared, right? So that math is very nice. So if you're able to play with this thing here, you will see some things, right? Some weird things, but yeah. So I hope that you understand the property number 7. Let's go on to property number 8. Right, move on to property number 8. Basically the same as that, but again, the quotient, or looking at the quotient or the division, basically the same. It will be a m over b m, and then yeah, it's the same. And then if we have property number 9, we have a b raised to the power negative in that case. Now this one here, It's very important. Remember, if you go back to property number, where is it, property number 5, where we had a negative exponent and then we changed it to this form, just like this one here. So this one here is the same as 1 over b times negative 1 and then m, right? Okay, so this is the same as a b negative 1 and then raised to the power m, right? And then we can change this now to, you can say this is 1 over a over b raised to the power m, right? Remember, we have that 1 as a numerator there, and then basically everything comes down, right? And of course raised to the power 1, right? And then you can just do the math. 1 over a over b, then we're gonna times both sides by 1, which is timesing everything by b over a raised to the power m, and hence these two will move, and hence what I'm left with is b over a raised to the power m, and hence my final answer will be b m over a m, right? So to make this simple, what you do if you have a negative, you just flip around the bases, right? You just flip around the bases. So in this case, I'll flip b and a, and then basically the m will come inside, right? M will come inside, right? So those are the properties, or rather the 9 properties that one should know when dealing with the exponent, when dealing with the exponential functions, right? These are things that you have to note, right? So let's look at some examples, right? Let's take a look at some examples. So let's say we have 4x raised to the power 3, 2 cubed, or rather 2 over 3 times 5 x6 raised to the power of 5 over 12. Simplify this completely, right? The question says simplify this completely. Please do pause the video and attempt the question, and then check the final answer. This is 6, by the way, and check the final answer if they do correspond with mine. Okay, so let's first start to simplify what's inside the bracket. So we have x, remember this will be 3 over 4, right? Remember the numerator becomes the root, and then the denominator is the exponent of the base, and then this is times, of course, 2 over 3, then times 6 x 6 over 5, all divided by 5 12, right? And then now we look at our properties, right? We notice that, okay, here we are dealing with property number 3. Dealing with property number 3, whenever you have a base m times by another exponent, you multiply the exponents. Okay, so in this case we're going to multiply these two. So if you multiply the 3 and the 3 will move, and hence we'll have 2 over 4, which is a half, right? And then here again, this is that the 5 and the 5 will move, and then 6 over 12 is basically a half, right? Yeah, 6 over 12 basically a half. And then here you basically have a half times x a half, right? Now you can see that we have the same basis, meaning we are adding the exponents, right? So a half plus a half, it should give us x 2 over 2, which is the same as x1. So my final answer in that case is x, right? My final answer is x. Okay, so now let's look at another example. Example 2. Let's say I have 2 negative 2x. Okay, and then we have 125 negative 1 raised to the power x, all divided by 2x times 8 x plus 2 times 20 negative 3x. Now going back to our first one, to prove this answer, make x, let's say x is equal to 2, right? So if x is equal to 2, the answer that we get here, we said this answer here is equal to x, right? So meaning if x is equal to 2, then I'll plug in my 2 there. I'll plug in 2 there. The answer that I get should give me 2, right? So let us try that. So 4, and then this becomes 2 cubed, and then basically raised to the power 2 over 3. Okay, so this is 2 over 3. Then times 5, and then 2 raised to the power 6, all over 5 divided by 12, and then we get a value of 2, right? We get a value of 2, so meaning that our answer here is correct. Okay, so make sure whenever you're dealing with exponent, you always check your answer. Right? I've been saying this for some time now. So here again, saying simplify. Okay, so let's start with this one here. Looking at our property, right? Looking at our property, so here we can notice that, okay, we are dealing with property number 9, right? We're dealing with property number 9. So that means that, well, this is the same as saying 2 over 1 raised to the power 2x, right? And then basically we will have this one here, which is 125. Let's see, 125 over 1 raised to the power negative 1, then x, all divided by 2x. And then if you change the 8, you notice that 8 is the same as 2 cubed, isn't it? Right? So you have 2 cubed times x plus 2, and then 20, right? So 20 is the same as 4 times 5, which is the same as 5 2 squared, right? I think let me check. 5 perfect. Yep. So you get 5 times 2 squared. Or rather, let me not change it now. Let's say we have 2, or rather 20 over 1 times negative 3 raised to the power x. Okay, let me change this one too. Here, so this was negative 2 raised to the power x. Okay, so now this is what we get here. So now looking at our properties, you can notice that here we are dealing with property number 9. So we have these bases here, and then we have a negative, meaning you basically change the bases. So in that case, I'll swap 1 and 2, right? So meaning my 1 will be on top, my 2 will be at the bottom. So 1 squared is 1, and then 2 squared will be 4. This is going to leave it as 2 squared, and then times x. Right here again, we are swapping these two, so I'll have 1 over 125, and then raise to the power what? X. Then again here I have 2x times, again here I just put in that 3 inside, so now I have 3x plus what? Plus 6. And then times, I'm changing these two again, I'll have 1 over 20 cubed raised to the power x. Okay, so now let us simplify this further. Simplifying this further, we will get, now this one again, we're looking at property number 8, where the m will go inside. So here again I have 1 over 2 raised to the power 2x times 1, and then basically 125 is the same as 5 raised to the power 3, right? So we have that, I think, yes, and then all divided by if you add these two, remember if you have 2x times 2x or 3x plus 6, the bases are the same, we add the exponents. Therefore if I add the exponents, I notice that 3, or rather x and x are like terms, so meaning 3x plus x will give us 4x, then plus 6, so I'll have 4x plus 6, and then this times 1 over 5 cubed times 2 raised to the power 6, and then x. Okay, hope this makes sense. Hope this makes sense. And then yeah, just do the math, the basic math. I'm gonna take this one to the top, so I will have 1 over 2x times 3x all divided by 4x plus 6, and then times this is 1 times 3x times 6x, right? Yep. And then here notice that these two will move, okay, and then these two will move, and then we are left with 3x, right? No, we are left with 4x. Yeah, we are left with 4x. If we remove that, we are left with 4x. So meaning my final answer would be 2 4x all divided by 2 4x times 2 raised to the power 6. But these two will move, and hence I'll have my final answer as 1 over 2 raised to the power 6, which is the same as 1 over 2 raised to the power 6, which is 1 over 64. Oof, that was long, right? That was long. So let us prove whether we are on the correct path. So my answer was 1 over 64. Okay, so now let us say x now let us come on, let us say x is equal to 1. Let's say x is equal to 1. Now plug in the value of x in the original expression and check whether your final answer will give you 64. Alright, let us do that. So 2 negative 2 times 1 times 125 is the power 1 times 2 1, and then times 8 raised to the power 1 plus 2, and then times 20 raised to the power negative 3. Okay, so we do get a value of 1 over 64, meaning that my final answer is correct. Okay, so this is very important to note. The exponent, of course, when dealing with the exponential function, make sure that you understand these laws and properties of the exponent. So in our next video, we'll be looking at graphing the exponential functions, right? So thank you for watching. I'll catch you guys later. Cool.